The separation has happened. It has happened successfully, and I'm not surprised at all. Of course, the entire nation, the entire world is watching. What more can you tell us? What's next in store for Chandrayaan-3?
So now the two components of the Chandrayaan-3 spacecraft are separate now. So far we had the propulsion module and the lander module, which were one block. They were known as the integrated spacecraft, but now that integrated spacecraft is two parts. This is something that had taken place just like clockwork in Chandrayaan-2 as well. As the spacecraft reached its final orbit around the moon, which was roughly 120 by 120 kilometer circular orbit, then the orbiter separated and the lander module, Vikram Lander module, separated. This time around the same thing's happening, only that the nomenclature slightly changed. Instead of an orbiter this time around, they're calling it the propulsion module, and of course the lander maintains the same name. The lander is known as the Vikram Lander. So both of them are on their separate journeys. As ISRO has just pointed out officially, the propulsion module henceforth will continue to circle the moon in its orbit for a couple of years or for a couple of months, and in that orbit it will be able to conduct its studies of the exoplanets. It can look for planets with any signs of life. It can look for other celestial bodies that have the possibility of supporting life, and it will also study the Earth's atmosphere from that distance and polarization phenomena in the Earth's atmosphere. As far as the lander is concerned, this is the beginning of the job of the lunar lander, because the lunar lander is the one that carries the rover also within its belly. So this is the most crucial moment for the lunar lander, and here is when the final phase of the mission begins. This is the commencement of the landing phase of the mission, because now the lander is the only part of the spacecraft that is to complete its job. The other two parts have completed. The rocket's done its job. The propulsion module has done its job of taking the craft to a certain location in the lunar orbit. Now the lunar lander's journey begins. This is when the lunar lander, you had pointed out just a while back that the lunar lander will test its electronics. Let me give you some specific details. The lunar lander will be testing 4 engines on board. So all these 4 engines are to be fired in different combinations. ISRO will be testing them anytime from now. These engines are being test fired to ensure that these engines have what it takes to slow down the spacecraft. So the slowing down process itself is actually to slow down the spacecraft from a few kilometers per second velocity to 1 meters per second, which is the ideal landing velocity for the Vikram lander. Even 2 meters per second is acceptable. They've made it tolerant to even resist 2 or slightly more than 2 meters per second, but the ideal landing velocity would be 1 meter per second. So when an object is, literally falling at multiple kilometers per second, there is no atmosphere on the moon to actually slow it down, especially when a space shuttle or when any other reusable rocket is re-entering the Earth. The atmosphere does the job of slowing it down, and once it enters the atmosphere, there is the dense layer of air, and you can use a parachute to slow down. But on the moon, you don't have that luxury. There is very thin atmosphere, so the impact of atmospheric drag is negligible. So the spacecraft has to use its own engines, its own means to slow itself down. So now all eyes will be on the lander module, which is the Vikram lander, and of course its various sensors. There are multiple cameras on board. There are maps that are programmed on board. So you might wonder, how is this lander managing this entire process autonomously? Because it takes at least 2.5 seconds to communicate between Earth and the lander. That's the kind of distance we're dealing with, 3.84 lakh kilometers. So the lander actually has a great deal of software and artificial intelligence built into it, such that it takes decisions based on preset commands. So it will analyze its maps, onboard maps, and look at the lunar surface and then figure out which is the most appropriate site for landing. It will activate its cameras, it will activate its altimeters, it will activate its sensors. Each one of them will work with the other to ensure that the lander gets clear decision-making data to be able to execute the lunar landing on August 23rd. So this is what we are looking forward to in the coming days. The sensors will be tested, the engines will be tested, and of course thereafter there could also be more images and videos that the lander will be sending from its own cameras. Shivan.
Siddharth, now, there was a little confusion, and a lot of people have had this question. Chandrayaan-2, what happened with it? How far is that stage from where Chandrayaan-3 is right now? And when do we hit that crucial stage where Chandrayaan-2 could not move further from?
So Shivan, Chandrayaan-2 in fact was just barely half an hour away from making history, to put it plainly. it was barely half an hour to 20 minutes from making history, because it was in the wee hours of September in 2019 that Chandrayaan-2 was expected to make its lunar soft landing, but barely 2.1 kilometers above the lunar surface, which is the final leg of landing, when the engines are fired, when the engines are in fact retro-fired. The engines are typically fired to boost a spacecraft, but in this case the engines are fired to deboost the craft and slow it down. So at that phase, what happened, there was a chain of errors. It was software error, it was sensor error, hardware error, a chain of errors. In fact, ISRO has also just mentioned that it was a chain of errors that led to loss of communication. Initially, ISRO said it was loss of communication, but thereafter ISRO understood that loss of communication was not a snapping of the communication link between the craft and its orbiter and its Earth station, but what took place was a fatal crash landing. So the craft has to be slowed down to 1 meter per second or 2 meter per second to soft land on the lunar surface and to survive that landing. But what happened to Chandrayaan-2 was that the velocity was much more than expected, and the craft crash landed on the lunar surface, and there was nothing left of the craft. Essentially, a sort of impact like that on the lunar surface would mean fatal for any craft. So if it's not slowed down effectively, and not just slowing down, we have to remember that the craft has to be oriented correctly. Its legs have to be down, and it has to be facing in a certain upright manner, and that's when the landing can be successful. So all these factors need to be taken into consideration for a lunar landing, and Chandrayaan-3 spacecraft is at least 5 days or 6 days away from that milestone, because from 30 kilometer it will be brought down to 7.3 kilometer, and then it will be further deboosted in a series of braking maneuvers where the spacecraft sort of fires its engines in a way that it applies brakes effectively, and then it comes down and then does the soft landing. So we are at least 5 to 6 days away. August 23rd is the D-Day for ISRO. That is the day when ISRO will hope to make history. So we're at least 5 to 6 days away from the phase that Chandrayaan-2 was last seen in action. So Chandrayaan-2's lander was last seen in action 2.1 kilometers above the lunar surface. So that was also what led to the heartbreak among the ISRO scientists, because everything had gone perfectly until that moment, and in the final few minutes or seconds of that mission being accomplished, they realized that the communication link was snapped, and also the graph that was tracking the trajectory showed an extreme deviation from the ideal path. So this gave them adequate hints that the craft was not slowing down as expected, and once the communication link was snapped, they knew something was amiss, and thereafter they analyzed the data and they understood that it was over for Chandrayaan-2's Vikram Lander. But ISRO, we can tell you very surely, that has learned crucial lessons from what happened last time. At least 2 years of testing, hundreds of tests of the new spacecraft to ensure that all possible avenues of errors, all possible eventualities on the lunar surface are calculated. All of that has been done to ensure that ISRO can get it done this time, and ensure that India's is the 4th flag that will soft land on the lunar surface.
Absolutely. India is going to have its Tiranga on the moon in a matter of days now. Siddharth, I also want to now quickly go over this tweet that has, I'm going to call it this post on X, which ISRO has just put out just a few minutes back. We had it flashing on our screens as well. Thanks for the ride, mate, said the lander module. LM, the lander module, is successfully separated from the propulsion module, and LM is set to descend to a slightly lower orbit upon a deboosting planned for tomorrow around 1600 hours. Can you explain this one sentence that ISRO has just posted for our viewers? What do they mean when they say deboosting planned for tomorrow? What is going to happen tomorrow at 1600 hours?
Shivan, yeah. So deboosting is essentially the term that is opposite of, boosting a spacecraft or pushing the spacecraft further away. So essentially, when you saw the initial few weeks of the Chandrayaan mission, or even until this week, what you saw Chandrayaan-3 doing was it was pushing itself into an orbit further away from a planet. So when it was pushing itself away from Earth, it had to boost itself. So it had to fire its engines in the same direction of travel. So it gains more velocity. More velocity means it's pushed to a higher orbit. It's pushed to a further altitude. So if you fire the engines in the same direction of travel, you go faster. But what you do in space is to slow down a craft, you can't hit the brakes like you do on a conventional vehicle that you use on Earth. So what do you do? The same engines that you use to go faster, you use the same engines in a reversed manner to go slower. This is what ISRO calls deboosting. It's also called engine retrofiring. It's a scientific term, which means backwards firing. So the spacecraft is tilted in a certain degree to the opposite direction of its original direction of velocity, and then the engines are fired. So what happens if you are pushing and pulling simultaneously? simultaneously, you slow down. That is exactly what is being done to the same spacecraft. It's moving in a certain direction, but the engines are fired in a different direction, thereby slowing it down. And slowing down effectively in orbit means you are brought to a lower orbit and you are orbiting closer. So this deboosting is a gradual process that will be undertaken over the next couple of days. Of course, the first one for the lander module will be tomorrow. After that, there will be other deboosting. So in fact, this landing itself is divided into multiple phases. One is known as the hard braking, where maximum velocity of the lander will be reduced. Then it's called the attitude hold phase to ensure that the spacecraft is oriented perfectly. Thereafter, there is a soft braking phase, and then there's the lunar landing phase. So it is in multiple phases that ISRO wishes to execute its lunar soft landing. So we've just commenced that final phase where the lander takes over all those operations, and in the next coming days, we'll also get to see the different functions that the lander will perform in terms of slowing down, in terms of orienting the craft, in terms of identifying the landing spot, in terms of zeroing in on how and when it wants to commence its landing. So there are so many procedures that are to be carried out in the next coming days. But of course, the Indian Space Agency is fully prepared for this kind of a challenge. They're maintaining cautious optimism this time around because they've learnt their lessons. And as far as lunar landings go, it's always complicated. But as far as scientists are concerned, that's what they're here for, to ensure that these unimaginable challenges are undertaken effectively and they can put a smile on billion Indians' faces. Shivan.
Siddharth, I know I have been on you with all the details that we need to get from you, and pick your brain on all the information that you have on the Chandrayaan missions. Catch your breath very quickly. I want to take your view on this as well, that the lander will photograph the Pragyan rover, which will deploy its instruments to study seismic activity on the lunar surface. What's next when it comes to the Pragyan rover photographing, taking photographs and of course studying seismic activity? Is this also part of the mission? What else is in store when it lands?
So typically this is just a repeat of what was intended for Chandrayaan-2. In fact, much of Chandrayaan-3 is a repeat of Chandrayaan-2. There's, in terms of the equipment on board, in terms of the systems on board, most of them are just a repeat of what the predecessor mission wanted to accomplish. Because if we look at the lander and rover, they're also named the same way. The Vikram Lander, of course, a tribute to Dr. Vikram Sarabhai, the founding father of the Indian space program, a visionary industrialist, but he dedicated his life to astrophysics and to ensure that the Indian space program benefits every common man. And today it's benefiting fishermen, it's benefiting common people, it's benefiting the common people by warning them ahead of cyclones, it's benefiting the government. So this is Dr. Vikram Sarabhai's vision that space technology, however sophisticated, must reach the last citizen of the country, and that's what it's happening. And aptly, ISRO has named the lander after Dr. Vikram Sarabhai, and Pragyan the rover, which means curiosity and intelligence. Let's remember that the rover's work starts after the soft landing is a complete success. So as far as the soft landing is concerned, the four-legged lander will have to deboost itself, will have to gradually come down and vertically land, just like we would see a helicopter doing. So it will have to come vertically land by firing its engines in a different combination. And then after soft landing, the first function, the reason why the landing is happening on August 23rd is because August 23rd is the beginning of the lunar dawn. A new dawn breaks on the moon on August 23rd. So which is why ISRO has planned it at that very time. So August 23rd, the day breaks near the landing zone, and that time they will have ample availability of sunlight. So when Vikram Lander lands, it will be able to deploy its solar panels. The solar panels will be able to harness the power of the sun and generate electricity. Likewise, it will be able to charge all its systems and batteries and get ready. So ISRO's intention itself is that its mission should work for 14 Earth days or 1 lunar day. It's after the landing in a couple of hours that the Pragyan 6-wheeled rover will be deployed. And that's when the rover will start its work. And within visual range of the lander, it will traverse the lunar surface and conduct its scientific experiments. Shivan.
All right, Siddharth. Thank you so much for all those updates. We're going to let you go now, catch your breath. And of course, lots in store in the next week itself. We are tracking all the developments coming in from Chandrayaan-3 right here on WION. I'm Shivan Channa. Thank you so much for tuning in.